Hello fellow modelers, 3D and car enthusiasts, wherever you are. Today we're gonna cover the final part of the inlet manifold we started on the previous video. This time I decided to record each phase of the process, so you can follow along and watch my workflow, and maybe let me know what you think about it, what could be improved or done differently. I'm definitely interested in each opinion, so don't hesitate to leave a comment down below. I hope you'll enjoy the video, and if you do, please consider to subscribe to the channel. It will really mean a lot to me. So, in case you missed my previous videos, building up on previous steps is the name of the game here. I created a sphere just for reference, but I'm actually going to start from the central inlet mesh that I already modeled, and the very first thing to do is to isolate the profile where the two separate parts connect to each other. So I just press Shift D then P separate parts to do that. Back to object mode, select the new created object, then we go back to edit mode, press 2 to select edges, then we Shift Alt click the outer loop and the holes profiles, E to extrude, and we try to set it at the same width of the opposite border. Then we select the profile section with L and duplicate it with Shift D to snap it to the front. A to select all, M to merge by distance. Let's isolate the current piece in the viewport with numpad/, and then we start working our way out from where we started. Still in edit mode, we add a new V-sphere and dial in the numbers to make it match our existing geometry. Now, since the sphere and the profile are the same object but still two separate meshes, we can easily select one with L and hide it with H. With Alt-Z we go into X-ray mode, drag select the vertices we don't want and just delete them. And now we press Alt-H to unhide, Alt-Z to go into solid view. Notice we have the hemisphere outer loop already selected, so we can right click it and mark it as a seam. So now we can press L to select it, Shift D to duplicate it, and Y to constrain it onto the Y axis, and then we try to match the vertices along the geometry. And when we are all set, A to select all, M to merge by distance. Here we are quickly removing the inward vertices of the hemispheres since we don't need them. And now we're ready for the tricky part of this piece, which is the actual main air inlet. As always, we try to keep it simple, so we start from a circle with a matching number of vertices. Then we try to position it. What we know from reference is that it's slightly lower and pointing downwards, so this part is a bit of a trial and error. We extrude a circle, match its length with the opposite hemisphere, and then it's a matter of test fitting it in position, using G to move and R to rotate. Once we get close to the final position, we can start the connecting phase. And what I find important here is to be aware that this part is less straightforward than you would imagine. You'll often come to points where you need to try different solutions topology-wise in order to identify the approach which is close enough to what's ideal. Here you can see a very self-explanatory demonstration of this concept. I struggled with the part where the cylinder merges into the sphere, and I tried many solutions, either moving and sliding vertices towards a smooth transition, but nothing seemed to really work. And even after a few tries, there still was a noticeable bulge. You can see me trying to use right-click and smooth vertices, which I use a lot in these cases, but this was one of them in which it only worsened the problem, so a no-go. But what eventually led me to the final shape was deleting the whole problematic area and use the automatic fail from vertex feature of the F2 add-on, which is never praised enough. by the way. This helped position the new faces with the optimal normals and literally saved my day. So don't be afraid to experiment. Just put good use into practicing moving and sliding vertices around, that is G and double G by the way, and maybe remember to have enough undo steps in the settings. Now it comes to the part where we have to fill the rest of the mesh. The only precaution here is to maintain a full loop going around the original shape to guarantee even topology in a critical area. The focus is to limit the usage of reductions on flat spots. The next few minutes show my process trying to find a way around how to better join the vertices together. You can see that I try to focus my attention on the whole area, not only the one I'm currently modeling. But again, it's trial and error. You want to plan every move and try to come up with the better solution you can find. Something I didn't mention a lot is how vital custom orientations are in this kind of workflow. You can see how my list of custom orientation is pretty crowded in this project, but for this particular piece we only need two. The global and the one derived from the normals of the cylinder section, which is the one I'm using here to move its edge. When the base mesh is complete, it's a good practice to spend some time optimizing the topology. In edit mode, I generally use a combination of smooth vertices and edge loop space function. Once this part is also complete, we can duplicate the base mesh into separate object, escape to lock it in place, and disable its viewability in the viewport and also in the render. We'll use this copy later as a target for the shrink wrap and data transfer modifiers. Now we're going to add the coils mounting columns. These are essentially cylindrical extrusions on the side of another cylinder. After we define an area, we then create an inset with I, then we use loop tool circle function and extrude that. We add some loops with Ctrl R and an inset with I to support the shape. You can clearly see some pinching on the mesh as a result of the new added geometry, but we will take care of that later once we apply the shrink wrap modifier. Once we are happy with the shape, we can then duplicate and paste it where intended on the rest of the geometry. Here I press S-1 Enter to invert the copied mesh on the local X-axis. And then it's just a matter of adjusting the vertices to match that side of the cylinder. We proceed to even out the vertices horizontally by using edge loop space function. Then we can copy the columns again. It's time to tackle the triangular supports at the sides of the columns. We start by adding a simple plane and then we model it into a triangular shape. Let's add some loops, fill the sides, inset them, optimize the overall topology, and then we can remove the unwanted faces along the edges that will be affected by the shrink wrap. Now, with the corresponding selected vertices, let's create a vertex group and assign it. And of course, let's not forget to add a subdivision surface modifier, set it to 2, and a bevel modifier, limit method to weight and width type to width, 2 segments and an amount of 1 or 0.5 mm if you want sharper edges. We can now select the diagonal edges and bring the mean bevel weight cursor to 1. We can finally add the shrink wrap modifier, set the vertex group we just created and target our mesh. Then we duplicate and move accordingly. Now this element in the middle is somewhat connected at the center, so we must join the 2 separate objects into one and quickly remodel the middle part while adding some more loops to support it. We are definitely at a good point. The next thing on the list are the infamous stripes on the top of the inlet. You probably already seen how I did them on my previous video, so here I'll give just a quick breakdown. They basically have both a shrink wrap and a data transfer modifier. This technique allows for smooth junctions in rendering, and I use it extensively in these cases. Since I already have an object with the correct modifiers, I just duplicate a part of it in edit mode and then P to separate by selection. This way everything is set up and ready, and I just need to change the targets. I usually try to have the shrink wrap by getting the vertices closer to the intended surface, but anyway, there's always the need for some adjustments along the way. You can see I have 2 vertex groups already set. One is called shrink, the other is called walls. Both groups have a distinct shrink wrap and data transfer modifier. Shrink vertex group targets the main mesh, while walls vertex group target the vertical part. Next, I want to focus on the text markings. They are quite common on mechanical pieces, so here's a quick breakdown on how I do these. Obviously start from the text tool, which is native in Blender. Once I found out the right font, I convert it to a mesh. But the conversion is usually very rough and unoptimized, so I spend some time getting rid of unwanted edges, insetting faces, and trying to obtain an at least acceptable topology. When this is done, I extrude my result, then I select the base loop of each character, right-click, go to Mesh Tools and select Offset Edges. Since we are dealing with very small parts, the width will be very low, like 0.01 or so. In the lower left dialog box, we also change the first entry from Offset to Extrude. Like many similar functions, if you already set your own parameters at least one time in the session, the values are kept over for every next reiteration. And then, similarly to the stripes, the extra face loop at the base will also be part of the vertex group that will be used with the shrink wrap and the data transfer modifier. Remember to apply rotation and scale every time you resize or move any object. And this is basically it. Since this part is symmetrical on both sides, we just have to do one and then mirror it to obtain its identical twin. Pretty clever, right? And by the way, if you made it this far, thanks a lot. I leave some of my experimentations with the shader editor so you can follow along and have some fun with the nodes I came up with. This project will be entirely procedural, so I'll probably cover that more in my future videos. I think the next steps on the engine will be the coils, the spark plugs, and all the relative cables and fittings. And if you fancy the idea of following me on the perilous journey about modeling and animating a whole Ferrari F40 engine, please consider subscribing to the channel if you haven't already, or leave a comment, or maybe both. I'll see you all on the next video. Until then, stay safe and have fun.